Awesome. Let's go ahead and start then.
Sure thing. I believe I have permission to share the screen. Awesome. Cool. Is that the right screen? Everybody see it?
See it.
Awesome. Well, welcome to the MTConnect tutorial presentation presented by a member of the Purdue Analytics Indiana manufacturing team. My name is Sam Stencel. I'm a graduate research assistant at Purdue, working at the Indiana Manufacturing Institute. I also drew the short straw. Some time ago, we managed to be able to export some of our data in MTC format, which is what brings me here today. I will start by briefly introducing MTConnect and give a similar introduction to the LIMS device that we use. I will talk about how we're using MTConnect data and go into the software and hardware details for the LIMS. After, I'd like to briefly talk a bit more about the LIMS capabilities and provide some additional information about I learned when I first just started to use the system. Finally, I'll open the floor to any questions, comments, or concerns anybody has. So as it shows here, I'd like to start by giving a brief introduction of MTConnect. The MTConnect standard offers a semantic vocabulary for manufacturing equipment to provide structured, contextualized data with no proprietary format. MTConnect uses a programmable adapter to read the data of devices and then presents the data in XML format, where an agent is programmed to retrieve specific information via HTTP from that address. It's open source, meaning that if you have the skills, you can create your own MTConnect adapter and agent to get the job done. It's primarily used for machine monitoring and data analysis, so you can monitor machines on a shop floor without having to be there and analyze the data however your research demands. However, you would need a secondary application to control the machines since MTConnect is a read-only standard. Now let's talk about the star of the show. We are generating MTConnect data with the help of the Learning Integrated Manufacturing System, or LIMS for short. The LIMS device is an operator-focused manufacturing control system that offers out-of-the-box wizard-based machine integration with the majority of both the subtractive and additive manufacturing world. It's a handy little system that I'm still getting used to, but we have been working with it for a couple of months now. While it's still an out-of-the-box system, it's definitely not plug and play. The LIMS device is accompanied by Solution Builder and Solution Engine. Solution Builder is the application that was created to serve as an interface for the system and offers configuration and customization abilities. Solution Builder provides a unique portal into the entire system of engines, databases, and cloud connections to allow for configuration of all aspects of your IIoT application. It's where most of your device configuring and connecting takes place. Solution Engine serves as the application that connects various devices to the LIMS device. It is a platform-agnostic application that runs on gateways as close to the data collection point as practical. Solution Engine provides connection to the sensors and data creators through a broad range of protocols. This program acts as its own adapter, if you will, with the Solution Builder acting as its own agent. Again, with that brief introduction to the system and the software, I can tell you the simplest way to generate MTC data using it. I'll detail it later, but assuming that all the software is downloaded and configured correctly, the first step is to use Solution Builder interface to connect to Solution Engine. We connect to the Solution Engine application by inputting the host address that the Solution Engine is currently running on and the port it's trying to communicate through. Once that connection has been made, you're exporting MTC data in XML. All that's necessary to view it is to navigate to your favorite web browser, type the IP of the host address followed by the port number, and /MTC/current/. You'll see all the data that the engine is pulling in MTC format at that moment, ready for use. That's it. Now you're exporting data. Any questions? You're probably thinking that's suspiciously simple, and you'd be right. If you take a closer look at the data, even if you can see the data that is being exported is just the data that gets naturally uploaded when you first connect a machine. You'll get engine information like date, time, memory capability, and more, but everything else that is being uploaded will be data items without any important values. The types of data items that let you know if something is connected or not, like whether or not a service is running. In order to start exporting relevant data you want to know, there's more to discuss, especially when it comes to hardware and software setup. Now, there are two main ways to connect your devices, but I find that it's best to explain these ways based on what you're connecting. Say you're hoping to connect a machine like a 3D printer or a milling machine. The easiest way to make this connection is by using the machine wizards that Solution Builder has created. For additive manufacturing processes, they've made wizards for Marlin printers, EOS, Stratasys, TrumpF, X1, General Electric, Juggerbot, Renishaw, and more recently Octoprint. They have a lot. These wizards require at most like 5 input fields to connect the devices and see what data they have. For subtractive manufacturing processes, there are wizards for FANUC machines, Haas via Ethernet and serial, Mazak, and Themwood machines. Much like the 3D printers, there's little input required to connect these machines to the system. In the past, I was able to connect a Stratasys F370 printer that we have at the Indiana Manufacturing Institute using its respective wizard quite easily. All the machine asked for was the name of the machine, the model, its IP address, port number, and the refresh rate that I wanted for the data. After that connection was made, I was immediately able to see information about the printer, such as the material currently being used in the printing operation, the commanded oven temperatures compared to the actual temperature, the voltages and current draw, tool position, and more, all by simply using just one of the wizards they have. Currently, we are connected to a mini CNC that we purchased from a local supplier here in Indiana. We are able to export all sorts of data, the position of the tool in the machine coordinate system and work coordinate system, the spindle speed and feed rate, program information like the title, line number, G-code command being executed, etc. However, I'm bringing this up because the mill that we are using does not have its own wizard. It's a small local supplier, so I don't really expect the developers of the LIMS device to include a wizard for them. However, the stars did seem to perfectly align, and we were able to get this data since the controller software we were currently using was getting an adapter built for it by the developers of the system. Conversation for another time, but if you've heard of it, the controller software is Mach 4, and there's an adapter for it in case you're using a machine that uses that. Now, the wizards are the easiest way to connect to the machines, and sometimes you can get lucky with your controller software like we did. But what if you weren't trying to connect a machine, but rather some additional sensors for research? The LIMS device has various I/O methods of connecting to any device sensor you could want. Just in the drop-down menu, we can see it has BACnet Discover, an OPC and OPC UA browser, Ethernet IP, and Vonix Modbus and Modbus server. So if you desired, you could connect devices with any of these methods. Also, you can see in the top image, the T380 expansion I/O kit in the LIMS device that would be used for manual connections via wiring. So there's a lot of options if you want to connect a sensor outright to the LIMS device. Before we got into using the LIMS device for our research, we were already using a sensor to gather data from one of our machines using Modbus protocol. With a RS-45 to USB adapter, a Python script, and Excel, we got the job done before. However, when we got the LIMS device, we wanted to add the sensor to the new system and generate data from it instead of the Python script, Excel, Hardware-wise, all we needed to do was transfer the USB plug from the computer to the LIMS box. Software-wise, we needed to re-register the device, which required almost the same amount of work that we put into connecting the device originally. Solution Builder asks for the port we connected the USB to, the port information, the device group, register group, and information about the individual registers we were trying to read. Don't get me wrong, we didn't have to rewrite an entire Python script to output the data in a format we could read, but the process of adding the device did take a little time. So if you've already got stuff set up, it may require reconfiguring in Solution Builder. This, of course, were the steps we took to add our specific sensor, so different sensors/devices will produce different results. Overall, the process of adding the sensors via the LIMS device is less time-consuming as opposed to the alternative, as long as you know what you're doing. So that ends the section that discusses software setup. Now it's the time to tell you that once the device is connected to a system that is currently running Solution Engine like a computer or the LIMS device, and it has been configured properly in Solution Builder, all data from that source has been shown to produce in Solution Builder. Sorry, just double checking it. It is all exported in XML to the host address of the Solution Engine that it is connected to in MTC format. Sorry, I butchered that sentence. At this point, you've managed to get not only the standard data that was acquired at the start, but also all machine and sensor data if it's connected. In this image, you can see some of the machine data that we were able to get, like I had mentioned earlier. Next, I want to discuss how everything should be set up physically, so hardware setup. Since there are many ways to connect your devices to draw data, there are many different ways to configure the hardware. In the spirit of preventing headaches down the line, it's easier to connect the LIMS device and all other relevant machines and sensors to a network using the same network device, be it a switch, router, hub, or anything. Doing this makes it easier for Solution Builder to discover the IPs of the other relevant devices for easy connection. We ended up using a network switch, but also added a router in case we wanted to connect any devices wirelessly down the line. In case you're curious, and correct me if I'm wrong, adding a router to a network switch can sometimes be as easy as just connecting the router input Ethernet cable to one of the network switch output cables, pretty much running network switches in series. In total, I had 3 devices connected to the network switch, the LIMS device, laptop 1, slide behind. In total, I had 3 devices connected to the network switch, the LIMS device, laptop 1, which was used to run Solution Builder, and another laptop that was used to run the controller software for our machine. You'll see 5 cables because 1 connects to the Ethernet port in the wall and 1 connects to the router. This, of course, was a specific use case, as there are limitations that I had to work with when setting up my hardware. So with the purchase of the system, there are installation instructions for Solution Engine and Builder, which go over everything, and they don't take a long time. For software installation, you'll want to have a computer that will be running Solution Builder and is directly connected to the network device, your router or your network switch, for that easy IP connection. In our case, this was laptop 2 data. For the use of machine wizards, connect said machine to the network. Either Wi-Fi connection or Ethernet cable work just fine. Just make sure it's set up correctly and you don't get the IP address incorrect when setting up the wizard. In our case, the machine was not compatible with Solution Engine, but the controller software was. So we installed Solution Engine on the laptop that was running the controller software and connected the computer to the network switch. For external sensors and devices, you'll need to connect to a system that's running Solution Engine. The LIMS device has direct I/O ports, the RS-8045 connectivity and 2 USB ports, and it's running Solution Engine. The PC that's running Solution Builder also has USB ports depending on your computer that can be used. Just make sure to install Solution Engine on it before you try and connect it. In our case, we connected the sensors to the laptop running our controller for the convenience of having all of our relevant data uploaded from the same Solution Engine instance. I don't believe there was a limit to the amount of connections Solution Builder can have, so go crazy. Connect to 10 different computers with sensors all attached for all I care. Just remember, all that's necessary is that the system your sensors are connected to is running Solution Engine. That's pretty much everything that there is relating to hardware setup and software installation and configuration. Just like I said back in the beginning, the MTConnect data is already set up, but doesn't export any real data, anything that you might want. Connecting machines via wizards is a breeze. Connecting external sensors requires the use of piggybacking off a system using Solution Engine and requires configuring in Solution Builder. If all this is done properly, data is exported in XML to the IP address of the Solution Engine address that the machine or sensor is registered to. That takes care of the MTConnect side of the LIMS device. However, it's important to note that the LIMS device, Solution Builder, and Solution Engine can do a lot more than just export MTC data. If MTConnect isn't your thing, it's got MQTT compatibility that can publish messages and subscribe to topics based on configuration. Builder can record data and export it to Excel based off rules that you make. If I wanted to start collecting data on a sensor once a machine started, all I need to do is insert a rule that states something along those lines. In reality, rules like these can start and stop data collectors, send email alerts, display operator messages, and supposedly start and stop machines. So while MTConnect can only read data, Solution Builder would be able to write data/commands. You can practically create your own HMI for your device that shows you numeric data and even plot it in a graph. Here you can see I created an HMI that showed me all the data relating to our machine controller, specifically positional data and program information. It's got loads of things you can do. The only limit really is your creativity and what your objective is. Additionally, I have nothing but positive things to say about the lead developer of the LIMS device and related software, Nat Frampton. If I ever have a question about the system, I usually go to him with them. He's very good at what he does, and he can clearly explain why it's done. Following this, I've included a small section that includes some things I found out working with the LIMS device and solution software, and some tips and tricks that will aid you in setup and configuration of everything if you go for it. Earlier, I'd said that once everything is connected properly, machine sensors, etc., data is exported in XML, MTC standard format. I stated that all the data from that source is exported. When I said all, I meant all. When getting data from a machine, there's potential to get data you don't care about. In the past, I had asked the developers about this, whether or not manipulation of the exported data was possible, since we were really only using a small portion of it. What we were told is that the solution engine server runs on resource-constrained platforms and therefore are not tasked with presentation. Pretty much no. It's not currently an easily customizable platform like Solution Builder. It would require more in-depth going into the actual files and coding them yourself if you wanted to. It wouldn't be self-explained, it'd be something you have to know. If you're hoping to have this can be a limiting factor in the number of devices you connect a system to running Solution Engine and the refresh rate of your data. If you're hoping to have a very fast refresh rate, it'll be for all the data items from the source, not just the ones you want. If you're looking to optimize the process and get the fastest refresh rate for your relevant data to improve the quality of your research, keep this in mind. However, recently there was a workshop of sorts that the lead developer had in which he mentioned that they have created a GitHub page for the Solution Engine software where it seems you'll be able to do your own read-write operations of devices, components, and data items. So if optimization is your goal, all might not be lost. Next, the network you are operating on can become a headache to deal with, depending on the security protocols it has. If you plan on using a giant, one might say, campus-wide internet network, you might experience some difficulty. The LIMS device, Solution Builder, Solution Engine needs to be able to connect to the network and connect to other IPs, made easier if Solution Builder can search for other instances of Solution Engine. If your network limits some parts of a system's network discovery for all devices as a security measure, you'll have to manually figure out the IP of the LIMS device, probably through CMD prompt, via a separate computer, or you can interface to the Raspberry Pi the LIMS runs on if you know how. Port manipulation may also be required depending on the system you're using. In our case, port 8080 was not working for a reason we could not figure out. So we had to go into some of the software configuration files and change the port from 8080 to 81. This wasn't that bad, just some troubleshooting you might run into. IP addresses matter a lot. So much, in fact, that if the IP address of any system, PC or LIMS, changes because the network goes down or from some other reason, you'll need to reconnect all of your devices with their new IP, which means going into Solution Builder and re-registering these connections one at a time. The situation can worsen depending on the network security, like I detailed earlier. CMD prompt config files, the whole shebang. When connecting devices to the network originally, try to get them static IPs to avoid this potentially giant headache. This will probably involve talking to whoever's in charge of your network. Lastly, like I had detailed a little bit earlier, the refresh rate of data is not hard capped, but does issue a warning. If the rate is set below half a second, it will put additional strain on the system running the Solution Engine software. This is just a general statement because Solution Builder doesn't know the capabilities of your computer. Solution Engine runs on your system and uses its resources to export data. The better your system, the faster refresh rate and the amount of data it can handle. I'm not a computer science nerd, but I do have some knowledge. My best guess is that the computer part that would directly correlate with your RAM is your RAM, since it's for reading/writing data. If you got a lot of RAM, you're fine. If this becomes an issue, look into getting more. Well, this is the real end slide. This concludes the MTConnect tutorial presentation. If anybody has any questions, comments, or concerns, now's the time. I'll try and answer them to the best of my ability. If that doesn't work, I'll refer them to my colleague, Google. Apologies.
That was fantastic. I'm glad we recorded it because it was information dense. So I'm not an expert in this stuff, so I'm asking basic questions. So where do you get the Solution Builder and Solution Engine software?
So that software comes with the LIMS device. So you purchase it all sort of as a whole, and you get the software that the LIMS device runs on, as well as the engine, which can help connect to other devices if you have any.
So where is the LIMS device? Who sells that and where do you get that?
So it's sold by Solution Family. This is a device that we had prior to me actually coming in. Apologies. So it was sitting in a closet collecting dust somewhere, and we just found out that it fit our exact needs. So we started to work with it. But I believe it's Solution Family that sells it, but there are a couple of the people that also work with them to aid it, and you might get them from there too.
And they're not expensive, Mitch. They're about $5,000–6,000 a pop.
I'm curious if the other universities have questions or reaction to that. We can kind of discuss what that means. Or
And to add to your question, Mitch, so this was sort of the data part of the acquisition part of the data pipeline. Right. So in the talk on Monday that Dongyan perhaps I will give, that part will focus on what we do with that data, how we organize it, how it ends up in MongoDB. So that's sort of, and how we do analytics. So that's sort of the back end of the data pipeline once you acquire the data.
And to that point, and I imagine your seminar is going to be revolve around some of the concepts that you guys have shared with me and in the one video.
Yeah, a lot of it is in that one video, but there might be more details in it.
Okay, good. So I this is an overarching kind of observation or statement, but I think, you know, what we've all been struggling with for several months is we want to get to the data portion of it, but we're hindered by this. How do you get the data out of machines?
Yeah.
And we thought that the Energy Insights solution was going to be just handle that for us. And as we found out, especially the Notre Dame team has found out, Energy Insights platform pulls some data, mainly around just the electrical voltage and current, but getting machine data from MTConnect or whatever protocol, MyQTT or whatever, requires either additional modules within Energy Insights or some other technology stack to do that. And what you've just presented here, what Sam presented, is this alternative technology stack, so to speak.
Yeah.
So one way or another, it requires some hardware and software to get the machine data, and I don't see any way around doing that. So you might explore one or both options, either this or additional investment into Energy Insights that aren't necessarily included in the MVP package that are made available, or some other solution might be out there. But either way, if it's a minor cost, you know, single digit thousands of dollars, I think we just got to lean into it and figure it out. And one way or another, we'll figure out how to cover the cost of that. You know, I don't think there's any reason to let small dollar costs like that hinder us on the timeline.
No, absolutely, Mitch. And this is what I was saying. These are not expensive devices. In fact, if you tear the device apart, it's just a Raspberry Pi with an analog digital converter and a bunch of analog inputs into that Raspberry Pi. So the device itself is quite trivial. If you look at the hardware, its hardware cost would probably be no more than maybe a couple of $100, but it's all the software cost and everything else. So, but even in totality, it's a relatively inexpensive device. And the data backend is all open source. It's all either software we put out or it uses public domain software. So you could set it up on your laptop and start collecting data into databases. So I think this is one whole solution vertical, and the Energy Insights certainly is another one, and we will push both of them.
And there are probably other solutions.
Absolutely.
But I think that the big aha here is there's no way to avoid getting our hands dirty with trying to implement some type of technology stack to get data off of machines to the point where we can start to analyze data. And what I'm hearing is that the Purdue team has been doing that and feels comfortable with that, and as evidenced by his tutorial. I'm kind of curious what Notre Dame and IU think of that, if they knew that they would get to this point and need to do some of this, or do you see the path forward, or is this kind of, surprise?
So Mitch, just to be sure, just to get MTConnect data, you don't necessarily need a LIMS device. What you need is to set up an MTConnect server. Okay. So and so there's the MTConnect source, there's the MTConnect server, there's an MTConnect connector, as we call it, and then of course there's the data backend. Okay. So there is a way to set up an MTConnect server independent of a LIMS device as well. But this LIMS device makes it very convenient to be able to sample any number of sources and pull it all together. But if you only had one Mazak or one Tormach machine, and all you wanted to do was to set up an MTConnect server for it, that can be done without the LIMS device.
But how would we go about doing that? Are there tutorials for that, or is there open source software, or is that
open source software? You can actually download open source MTConnect servers.
Okay.
We should be able to do. I mean, we do that all the time. I don't know if Sam, you set up the MTConnect server, right, for the Herco machine?
For the Herco, no, I did not. That was a separate person. Sorry.
Okay, so we can maybe it was Yunsub. So we can do that if that's the interest here.
Hi all, I have a following question. I'm Ramandeep from Notre Dame. So from the past week, I've been looking into getting data using the MTConnect and around this. This was actually very useful, but like I'm also no expert around this, but I was just going through like how to get data. So I got into like MTConnect adapter within the Ignition software. So how similar is this to that, or how different is this from that? Because I think the Ignition software we already have with the Energy Insights module, at least for 1 year, and then we have to pay from the next year or something like that. But so
as I mentioned, you don't even need the Ignition software for this. You can actually download a public domain MTConnect server if that's the only thing you want. I think what Ignition gets you is a whole bunch other dashboard type services that you get in addition to the MTConnect, just getting the data down. So we have a whole different software stack built. Like I said, on Monday, you'll probably see a lot more of that. We build these things called passports. We make objects of your data. We let you do analysis on that data. It's a whole different vertical. But if your only interest is in catching MTConnect data from a machine that you have, you can do it even without Ignition.
it just needs the MTConnect adapter connected to the machine. So in that case, like the machines should also be connected to the network.
The machine should support the MTConnect protocol. Yes.
Yeah, okay.
Any other questions? Well, Sam, thank you very much. And I think I will stop at this point recording, and we can just...
Does CR have a question? I think you're muted.
My microphone is off. I just had a really quick question, Anand. As far as because I believe during not last week's conversation, but the week before, Purdue had gotten its MVP kit and were getting things installed. As far as explicitly how you guys have worked to start to pull this data from Purdue's kit, is that something that y'all are going to cover on Tuesday during seminar, as far as like nuts and bolts of that?
So CR, I think the data acquisition part Sam covered today. We were not going to get into that again. No. But in the seminar, we'll talk about once you've collected the data, what do you then do with that data? So how is that data organized? What are the schemas? These basically all you get is a runtime stream of MTConnect XML objects. How do you organize them in some way? How do you then do analysis on them? That's what we're going to cover on Tuesday. Is it Monday or Tuesday? I forget.
Tuesday.
Yeah, I view this as this discussion as kind of part one for the universities here on Purdue sharing with Notre Dame and IU how to get the data through MTConnect, and then part two next week, what to do with some of the data, some way to approach it, and for the folks on this call, they just may need some time to think about that.
And to give you a preview on Tuesday, CR. So Sam and Matt and Mike, they're absolutely incredible. So they set up all these experiments. So we'll show how you can pull that data to do things like dimensional anomaly detection, energy anomaly detection, in addition to how the data is organized. And unfortunately, there's a bunch of stuff we cannot talk about because that's sort of in a control project. But even beyond that, we'll talk about that.
So we have that on Tuesday, and then next Friday, we have Cummins joining us on a totally separate topic, which is the safety topic. And so my apologies on that. The key person that's going to present had something unexpected come up last week, that she couldn't present. So that's why we pushed it to next week.
Okay, well, if there are no more questions, I will turn off the recording.